Welcome back, students. So in the previous class we have done the topic what? Last topic is mean terms, and we done some problem of mean terms. Okay. So in this class we study the next topic is Maxterm. Okay. In previous we study mean term. In this class we just start from the topic Maxterm. Okay. And what is Maxterm? Maxterm is sum of all the product of literals. And what is literals? I hope you remember. Literals is what? Either without bar or with bar. Okay? Means literals is a variable which is suppose x. X is a variable or x bar means x complement. That is called literals. Okay? And sum of this literal, sum of product of this literal. Like that actually you see, I show you. Is sum of all the literals with or without bar within the logic system. Okay, first of all, I write down the definition. You see, a maxterm is a sum of all the literals, sum of all the literals with or without the bar, with or without the bar within the logic system, within the logic system. See, and one thing, there is no need to be done the problem of this maxterm. Okay, actually in exam somehow maybe problem coming from mean term, not from maxterm, right? A maxterm is a sum of all the literals with or without the bar within the logic system, right? So next is important topic is canonical expression. Canonical expression, and that is very important. In last year final exam or previous of last year, there is a questions coming. What is POS? Means product of sum. There is two topic, POS and SOP. There is under the topic of canonical expression. Now we shall start that topic. You see, canonical expression. You see. What is canonical expression? A Boolean expression, composed entirely either of mean terms or max terms, is referred to as canonical expressions. See, a Boolean expression, mainly mean term is what? Mean term is product and max term is sum of literals. Okay, literally we can take like that. That mean term is product of literals with or without the bar within the logic system, and max term is sum of literals with or without the bar within the logic system. And that is the main concept coming in canonical expression. The Boolean expression composed entirely either of mean term or max term is referred to as canonical expression. What I have already say you that SOP and POS means sum of product and product of sum. Sum of product means this is coming under max term. Okay, or you can say sum of product means this is coming under mean term also, because like this sum of product, and max term is what? Product of sum. That is you say max term. This you say mean term, right? Next is You have to study what is SOP, sum of product. Sum of products. Okay, SOP. This is very important definition. Sum of product. Okay. You see, a logical expression is derived from two sets. Okay, first of all, you have to write a definition. Okay. Okay, definition. When a Boolean expression is represented, when a Boolean expression is represented purely as sum of mean terms. What I already say you, sum of mean terms. Okay, it is said to be in canonical sum of product form. It is said to be in canonical sum of products form. It is said to be in canonical sum of products form. Right. See. When a Boolean expression is represented purely as sum of mean term. Mean term is what? Product of literal. You see, mean term is what? Suppose x, y. This is mean term. Z, x. This is mean term. And when it is sum of this, sum of mean terms, it is called sum of product. This is called sum of product, SOP. That's very easy concept, right? Okay, there is some rule I show you. Okay, wait. So there is some rule. Okay, okay, there is not necessary. Okay. That is not necessary. Okay, I show you one concept. Okay, I show you one concept. Okay, there is some maybe coming in exam. That's why a logical expression is derived from two sets of non-values. Derived from two sets of non-values. Number one, various possible input values. Various possible input values. Number two, the desired output values. The desired output values for each of the input combination. For each of the input combinations. You see the two rule. A logical expression is derived from two sets of values. Okay. Number one is various possible input values and the desired output values for each of the input combination. You see, I show you a problem, means example you can say for SOP, okay. A logical network has two inputs x and y, and an output z. Okay, that is an example. Okay, this is example of SOP. The relationship between inputs and outputs are the relationship between input and outputs is to be input and outputs is to be as follows. What is the relationship? You see, when x is equal 0 and y is equal 0, then z is equal 1. There is some relationship, okay. We have to find the truth table after that. You see, second relation is between input and output, right? You see, when x is equal 0 and y is equal 1, then z is equal 0. Okay. Number third is when x is equal 1 and y is equal 0, then z is equal again 0. And number 4 is when x is equal 1 and y is equal 1, then z is 1. Now we have to make the truth table. The relationship is, see, what is the relationship between input and output values? You see, there is 4 means possible relations, okay. A logical network has 2 inputs x and y and an output z. The relationship between input and outputs is to be as follows. When x is equal 0 and y is equal 0, then z is equal 1. And x is equal 0 and y is equal 1, then z is equal 0. When x is equal 1 and y is equal 0, then z is equal again 0. And when both value will be 1, then output will be 1. Okay? See, now we have to make the truth table. How we make truth table? Using SOP, sum of product. Okay? See. So, in truth table we take variable what? How many variable? X, y and z. And there is possibility when 2, 3 variable, okay, x and y, okay, x and y. The truth table is, first one is what? X and input variable is y, means 2 variable, x and y. And when 2 variable, I already teach you, 2 to the power 2 is equal to 4 means 4 step. So what is the 4 step? 0, 0, 0, 1, 1, 0, 1, 1. And z is respective output. Means this is when both value will be 0, it will be, we take relation 1, 0, 0. 1 second. one mistake. If you see in the relationship, I told you, then when x is equal 1 and y is equal 0, then z is equal again 0. It is not correct, okay? My mistake. Z is equal 1. You see, in the relationship, you see, I can amend it. You see, when x is equal 0 and y is equal 0, then z is equal 1. Correct? Number 1. When x is equal 0 and y is equal 1, then z is equal 0. Okay, and when x is equal 1 and y is equal 0, then z will be not 0, z will be 1. You correct it in number 3 point. Means x is equal 1 and y is equal 0, then z is equal not 0. I say previously that 0, my mistake, okay? You just correct it, z is equal 1, and last one is x1, y1, z1. Means again I am saying, you just see x1, y1, that is 1, last one. Means okay, I starting from the first. Number 1 is what? x0, y0, z1, x0, y1, z0, x1, y0, z is equal not 0, z is equal 1. That is my mistake, okay, that was. Z is 1 and last one is x1, y1, x is equal 1, y is equal 1 and z is equal 1. Means there is 3 1 in output. Only second value will be 0, okay? You correct it. Okay. Okay, then you see 0 1 0 1 0 1 1 1 1. There is the what? Now we have to be write in product form. Product terms. Means you see xy see when 0, that will be in bar. Like that. You understood? What coming? This is 0 0 means x bar y bar. 0 1 means x bar y. 1 0 means x y bar and 1 1 means x y. Okay? And now we have to what? Adding all the terms of which output is 1, that z is 1, we get following. Okay, see. So what output value will be 1, that terms will be we adding. Then coming sum of product. That is product from, we have to find sum of product from. You see. Adding all the terms. Adding all the terms for which the output is 1. For which the output is 1, that is z is equal 1, that is z is equal 1, we get following expression. We get following expressions. What? Means we take from that 1 value, okay, number 1 means x bar y bar plus x y bar plus x y. That is the C. Means which value product value will become, that is that for respective value 1, that, okay, and that. No need to circle with the arrow direction in exam, just I show you for understanding purpose. That is. Means now see, it is an expression containing only mean term. This type of expression is called mean term canonical form of Boolean expression or canonical sum of product form of expression. Okay, last line you just, okay, I write it. That is the main answer. That is sum of product, SOP. I show you. I write down, say. So last line you write after this, okay? Below you write. Like that, this is an expression. Last you write, okay? After the writing the expression, in the below you write, okay? This is an expression containing Only mean terms. You see in the mean term, bar expression x bar y bar, that is all are literal, product of literal means what? Mean term. Okay, mean terms. This type of expression is called mean terms, mean term canonical. Mean term canonical form of Boolean expression or canonical sum of product or canonical sum of products form of expression. Okay. Okay. See. When this is an expression containing only mean terms, and this type of expression is called mean terms canonical form of Boolean expression or canonical sum of products form of expression. And last one questions we done here of SOP. Okay, that is very important. That may be coming in exam. Okay, in final exam also. See. Question says a Boolean expression means a Boolean function also is like this f defined on 3 input variables x, y and z is 1. Okay, a Boolean function f defined on 3 input variable x, y and z is 1. If and only if number of one inputs is odd, example you see, if f is 1, if x is 1 and y is equal 0, z is equal 0. Okay, and last question is draw the truth table for the above function express it in canonical sum of products form. See, what are the questions say? You see, this is the last questions of sum of product. Okay, a Boolean function f defined on 3 input variables x, y and z is 1 if and only if number of one input is odd. Mainly you see this is the input variable x1, y0, z1. The input 1 is for what? Only x, means odd number. If x is equal 1 and y is equal also 1, means how many value? 1 value. Even number, then f is equal not 1. Then f is equal 0. But, or if suppose there is suppose like that x is equal 1, y is equal 1, or z is equal 1, then f is equal 1. Means the 1, you understood the 1 value, the number 1 in input is in odd number. Then output will be 1. Otherwise it is 0. You see in our questions x is equal 1, y is equal 0, z is equal 0. Means the 1 in input is odd. That's why result is 1. For that condition we have to withdraw the truth table. Right? And we have to find the sum of product from. Have you understood the questions? Okay. You see. So, answer is the output is 1 only if one of the inputs is odd. Full stop. Right? All the possible combinations when one of inputs is odd are, you see, the possible condition is x is equal 1, y is equal 0 and z is equal 0, x is equal 0, 0 and that 3. You see, means odd value, means only one input value may be coming in. That is the example in questions, but possibilities is what? Maybe one value is in x or y or z. Okay, means in odd number. In this expression only one input, only one number value is only 1. In second option also and third like also. Okay. Now we have to draw the diagram for these combinations. For these combinations, output is 1. Output is 1. Otherwise, output is 0. Means this is a possible condition for which output is 1. For this also output is 1, for this also output is 1, for this also output is 1. Other than this possible value, output is 0. Means if suppose 1 is coming in twice, means what? Number of 1 is means even, and even means output is 0. As per our condition given by questions. Okay? So preparing the truth table for it. Now we have to be preparing the truth table for it as follows. Means below you make the truth table. Okay, I show you the truth table. You see, possible condition you remember. Okay, either x1, y1 or z1. You see, and after that we have to make the S of A, sum of product. So there is 3 variable x, y, z. So how many possible steps? 8 steps. 2 to the power 3, 8. Okay. X, y, z. Okay. We make it 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. So possibility is what? F means in here there is no, in here you see 1 is odd, means 1, 1, 0, 1, 0, 0, 1. You see. Means there is 3, 1. Yes, there is also, this is 0 because this is 3 na. Means only 1. In input only 1 value. Odd number means only 1 value. In here you see 0, 0, 0 means 0, 0, 0, 1. Only one input value, 1 value, there is output 1. There is only 1, output 1. Here there is 2, 0, 1, 1, 2, 0, 2, 0 and 3 is also for 0. Means only for 1. Only for 1. Okay. So, what is the min term? Products term or min terms? Means you can write like this directly, min terms. Or also you can write this product terms. Same thing. Here it is x bar, y bar, z bar, x bar, y bar, z, x bar, y, z bar, x bar, y, z, x, once again, okay, x, y, z bar, x, y bar, z, x, y, z bar, x, y, z. Yes, means for what for one value expression is what? This is right, and that will be our output. Adding all the min terms product from, okay, you write below, I write here, adding all the min terms or product from product terms, same thing, product terms for which output is what? For which output is 1, we get what? X bar, y bar, z plus x, y, z bar plus x, y bar, z bar. That is the result. You see, x bar, y bar, z plus x bar, y, z plus x, y bar plus z bar is equal f. You can write like this, is equal f. In one line you can write like this. Means, okay, I show you, x bar, y bar, z plus x bar, y, z bar plus x, y bar, z bar is equal f. That is your result. Okay. This is desired canonical sum product form. You can write like this. This is desired canonical sum of products from. Okay. That is the last question of sum of product. So, you see, okay, I'll ask, you see, means for only one input, the output is 1. And respective expression min term is coming from this expression, 0 means bar, 1 means without bar. And for one output, the respective min term will be, you just plus it. Mean that is min term product from and sum of product that is coming in desired canonical sum products form. Right? So, this is enough for this class. In next class, we study the topic of POS. Okay? So, thank you.